continue the previous video, that's for previous one, that's from this example, we see that the power from 0 to 2, 0 to 2, we get PT, it was equal 150 T, and from 2 to T to 4, we have make some mistake there, because it's supposed to be PT minus 5. I mistakenly put minus 50, but it's supposed to be minus 5 multiplied by minus 30 T plus 120, which is going to be equal 150 T minus 600. That's the value of PT from 2 to 4. Now we are going to sketch it. To sketch it, I have 0 from 0 to 2, I have to 2 from 4 to 4. Now from 0 to 2, what was the value of PT is 150 T. There is no B which is 0 here, meaning that it's passed in the origin, and the rate 150 here. So it started from the origin and we go to 150, the value of 52. Now from 2 to 4, I have what? I have 150 minus 600. From 2 to 4, I have 150 minus 600, which is going to be equal here 150. From 2 to 4, I have 150 T, supposed to be T here, 150 T minus 600, mean that if at 2 equal to, when T equal to, is going to be 150 multiplied by 2, 150 multiplied by 2 minus 600 is going to be minus 300, minus 300. So minus 300 is here. I'll have here at T equal 4. When I put T equal 4, it's going to be 0, because 150 multiplied by 4, 0. So it's coming from here to 0. That's the value of P. So from 2 to 4, I have the function of the power 150T minus 600. So when my T is equal to the 2 that is here, I will have 150 multiplied by 2, because I replace the T by 2, is going to minus 600, it will give me minus 300. So my power will come down to minus 300, start from here. When T is equal 4, it's going to be 150 multiplied by 4, minus 6 is going to give me 0, and will come to 0. That's the sketch of the power. The second equation. The second equation, it allows us to find the energy. To find the energy, we already know from the previous, we say power derivative of energy with respect of time. Now if I want to find the energy, derivative of energy equal the power multiplied by dt. Now if I want to remove this derivative, I have to integrate this one, meaning that the energy equal the integration of the power with respect of time. Same, I have to find the energy from 0 to 2, and to find the energy from 0 to 2, I have to derivative to integration of the power. What is the power? It's 150T dt. From where? From 0 to 2. 0 to 2. Now what is the integration? The integration is going to be 150 by 2 t square from 0 to 2, which is equal 150 by 2 multiplied by 2 square minus 0. And the 0 square means it's minus 0, which will give me 150 by 2 multiplied by 2 power 2 equal 300. I have 300 here. Now from 2t to 4, from t to 4 I have integration of the power. What's the power? The power I have 150 t minus what? 600 from 2 to 4 with respect of dt. Now when you integrate it of this one, I will have 150. I will have 150 by 2 t square minus 600 t, because the derivative of this one is going to be, the integration of this one is going to be 150 by 2 t square minus the derivative of this one is going to be 600 from 2 to 4, from 2 to 4, and you put everything, you will get, when you put everything you will get 150 multiplied by 2. We replace here is going to be 4 square minus 600 multiplied by 4. I have to replace the 4 in all minus, you replace, now you replace the 2, 150 by 2 multiplied by the 2 square minus 600 by 2, and you calculate it, you will get the energy. Let's do the question of that one. To find the energy, we found the energy from 0 to 2, which is the integration from 0 up to 2, the integration of the power. What's the integration of the power? From 0 to 2, the integration is 150t. So it's going to be integration of 150t from 0 to 2. You get 300. Now from 2 to 4, what is the integration? It will be the integration of the power. What's the power? 150t minus 600. You integrate, you get a value here, which is going to be equal 150. We have 150. If we calculate it, you will get the value. We have 150 by 2 4 square minus 600 multiplied by 4 minus 150 by 2 multiplied by 2 square minus 600 by 2 minus 300, which equal minus 300. So now I get minus 300 from 2 to 4. If we want to sketch it, I have from 0 to 2 and 2 to 4. From 0 to 2 I have 300 here, so it's going to be the constant value, constant. From 2 to 4 I have minus 300 here. That's the sketch of the energy. That's the sketch of the power. That's the sketch of the energy. Now we are going to see the different type of source, different type of source, different type of source. So in circuit 1 we have like dependent source, and independent source. So now if we say dependent source, means that it depend on something. The source can depend on something. But if we say independent source, it does not depend. It does not depend on something. For the independent source, in the source we can have voltage source, which is like this one. This one is voltage independent source. This value is, it will just to give me the value of this one. Let's say for example 9 volt. Let's say for example 9 volt. This source is independent source because it does not vary on something. It has its own value. We can also have current source. Current source, which this also does not vary on something. It has value we can to give me. Let's for example 2 ampere. This one, if we see this notation, means that we have independent source. If we see this notation, we have current independent source. Now, for the dependent source, same, we can also have voltage, but in this case, the voltage, it will depend on other parameter, and the notation will be like this one. Like for example, this one. If we see this notation, it means that we have it is a dependent source. Now, this dependent source can also it can depend on voltage dependent voltage source. Let's say for example, we have 3Vx. 3Vx means that the value of this, the voltage of this source is 3Vx because why? It's depend on a parameter Vx that we call dependent source because it depends on the value of Vx. If Vx equal to, the value of this source is going to be 3 multiplied by 2. If the value of Vx is equal to 4, the value of this source is going to be 3 multiplied by 4. We have current source. It can also, let's say for example, it will be 3Ex. In that case, it's going to be voltage dependent current source because it depends on a value, a parameter current Ex. It depends on parameter Ex. If the Ex equal to the value of this voltage, this source, the voltage of this source is going to be 3 multiplied by this current 2x. I can also have current source, currents, which will be notation of this one. Same thing. This notation is going to be like, it can be 2Vx, mean that it's going to be current dependent voltage source because it depends on a voltage Vx. If I have the value of Vx, I can also determine the current of this source just to multiply 2 multiplied by the value of Vx that I already found or given. It can be 2Ex, mean that current depends current source because it depends on a value of current Ex. If I have the value of Ex, I can directly determine the value of voltage of this current source directly. Let's say for example, I have this one is the independent source, but if for example I have this one which equal 3 which equals 3Vx, when Vx I get equal 4, so this voltage is going to be equal 3 multiplied by 4. Why 4? Because the value of Vx equal 4, which is going to give me 12 volt, meaning this source is 12 volt when the value of Vx equal 4. So we already see the different type of source. We see that it can be dependent source or independent source. When we say independent source, mean that the source has its own voltage without depending on another parameter. But when we say dependent source, mean that the voltage or the current of the source depend on the source, can be voltage source or current source, is dependent on another parameter. That parameter can be a voltage, can be a current. Thank you for watching.